This is an example of a very specific case of Alaska and a special surveillance system that was set up by an institute in the university there, and we'll see why that is. And I'm including it just as one podcast, basically because these kind of systems are also very useful for countries like India and the neighborhood, where rural areas do not always have quick and immediate access to primary health care even, and that may prevent people from seeking help, and also collecting data becomes an issue. So this is called community-based Sentinel surveillance as an innovative tool to measure the health effects of climate change in remote Alaska. So very relevant for developing countries with lots of rural populations. So how big is Alaska? So this is a map of US, where people in Texas always used to say they are the biggest state, but this is just a joke showing that in fact Alaska is much bigger, and you can see it stretches quite a distance when you put it on the map of the US. But surprisingly, the population is remarkably low. This is the population of Alaska from 1946 to 2019, so end of World War II here, Korean War, Vietnam War, pipeline construction, oil boom, financial recovery, and the US Great Recession, and the Alaska's own recession, and so on. Its population is barely 700 and some 40,000 or 50,000, but there is lots of very region-specific problems like employment and so on, and of course population is distributed very widely on these remote areas. Taking definitions from Wikipedia, Sentinel surveillance is the monitoring of rate of occurrence of specific diseases or conditions through a voluntary network of doctors, laboratories, public health departments, with a view to assess stability or change in health levels of a population. We are going to talk here specifically of climate change impacts, but it's still the same idea. It also describes the study of disease rates in a specific cohort, such as a geographic area or subgroup, to estimate trends in a larger population. So it could be a sampling kind of strategy. A Sentinel surveillance system is used to obtain data about a particular disease that cannot be obtained through a passive system, such as summarizing standard public health reports. Data collected in a well-designed Sentinel system can be used to signal trends, identify outbreaks, and monitor disease burden, providing a rapid economical alternative to other surveillance methods. And it's of course well suited for a state like Alaska, where population density is so low and people have specific cultural traits that probably prevents them from rushing to a doctor every time they have some health issues. And climate change is having a massive impact on Alaska already, because it's almost some part of it is within the Arctic Circle, which is experiencing the Arctic amplification or polar amplification of warming. Sentinel systems involve a network of reporting sites, typically doctors, laboratories, and public health departments. Surveillance sites must offer commitment to resource the program, a high probability of observing the target disease, a laboratory capable of systematically testing subjects for the disease, experienced and qualified staff, relatively large population with easy site access. Obviously, this is not the same that is being done in Alaska. So we'll see the book's definition here is that public health agencies rely on a mix of data to monitor disease and such contributing factors as environmental, economic, and sociocultural characteristics. That's Alaska. In areas with widespread access to robust healthcare systems, clinical data are usually collected in the course of health service delivery. In Alaska, that's the major issue. In this way, clinically based Sentinel surveillance systems allow public health scientists and policymakers to identify health trends. Nonetheless, Institute for Circumpolar Health Studies, situated within the University of Alaska, developed a system where it has collected data from other published reports on direct and indirect effects of climate, and then has done large surveys of people and their self-assessment, as we will see. That's part of the new way of doing things that's specific to Alaska here in its Sentinel surveillance. Previously noted direct effects over Alaska include increase in hypothermia, particularly among the elderly and very young, injuries, deaths, and illnesses resulting from storms and floods, increase in subsistence practice-related injuries and deaths. So livelihoods depend on various aspects of oil business, timber, fishing, crabbing, and so on that involve subsistence practice-related injuries. Indirect effects include changes in availability of subsistence food, resulting in increased reliance on expensive, non-traditional, and potentially less healthy food options, with an attendant increase in obesity, diabetes, hunger, and heart disease. This is very typical of Alaska. Damage to water sources and infrastructure due to erosion and subsidence. This is also part of the problem with sea ice retreating, land freezing, melting, permafrost thawing, and so on. Permafrost thawing is a big problem in Alaska, where houses sink, roads sink, buildings sink, and so on. Increase in respiratory ailments from changes in allergens and air pollution from increased wildfire activity. So the warming and insect infestations have created lots of wildfires. Encroachment of wildfire-borne, waterborne, and vector-borne diseases, mental health concerns, and loss of community identity. Okay, so here are the climatological regions of Alaska: Point Hope, Kivalina, Novatak, Nenana, Anderson, Healy, and Cantwell, and these regions here. So they are distinct in their marine, terrestrial, vegetation, mountain, and so on types of ecosystems. The ICHS study was designed in this way. There is a decision steps involving social science methods, with input coming from set surveillance goals, develop draft metrics, which are critical. They are, together with developing draft instruments and protocols, feed to identifying stakeholders and engaging communities. They embed instruments and protocols into surveillance toolkits for stakeholders, which feed into eliciting community input. That feeds the revising of surveillance toolkit or upgrading the surveillance system, which is then implemented, and stakeholder input is elicited. Stakeholders are basically people, communities who are involved in the surveys and doing self-assessment of vulnerabilities and priorities. Revise protocols and then feed it to analyzing surveillance inputs and develop prospective adaptation strategies. Everything is done as a co-production here. Assess community preferences and assess social and economic impacts of the options, and this is an iterative process with feedbacks, which then leads to assisting in implementing preferred options to deal with climate change impacts on health outcomes and health vulnerability. Okay, here are some examples of findings by regions. Residents in southeastern Alaska had 3 top priorities they considered linked to environmental conditions, so they have to be asked what they think. Unintentional injury caused by or related to extreme weather events were of concern. Food security, high levels of algae-related toxin in local shellfish when water temperatures rise, and then the resulting high risk of paralytic shellfish poisoning. Seafood, fishing are big business in Alaska, of course. Indoor and outdoor air quality, increased allergies, and mold prevalence. So warming, humidity, and disappearing, thawing permafrost are all conducive to these conditions as well, of mold and so on. Indoor and outdoor air quality. Residents of the interior region described a host of prospective causal associations to health phenomenon, such as respiratory ailments, asthma and allergies associated with wind-blown dust in the spring, increasing pollen levels in fall, and smoke from forest fires in summer. Water security, eroding riverbeds caused by melting permafrost clog water infrastructure unable to handle high sediment loads. I hope everybody knows what permafrost is. It's basically soil that has frozen, and there is a seasonal cycle. It can thaw near the surface during summer and then refreeze, but with global warming the thawing of the top layer has deepened and there is no refreezing in many cases, and that leads to all kinds of release of methane, puddle forming, sinking of land and buildings and roads, infrastructure, and so on. The following issues arose in the Northwest: food security. Unexpectedly intense storms and temperature trends weaken ice and exacerbate vulnerability to food insecurity. Air quality. Erosion exacerbated by storms lowers air quality. And water quality. Upriver erosion was a concern. So if you have early snow melt, permafrost thawing, mountain tree cover loss, and runoff bringing more sediments, and so on and so forth. Okay, so obviously each of such a system has to be set up in a place where the surveillance is carried on, but it gives a good idea of how a country like India or other countries in the neighborhood, or in Africa and South America, where people are spread out and don't have good access to primary health care and are experiencing climate change impacts on health, can set up Sentinel surveillance systems which combine instrumentation, surveys, crowdsourcing of data, self-evaluations, and so on to come up with adaptation options. Okay.